In this video, we are going to learn about how to use divisibility tests to make the process of simplifying fractions easier. The process of simplifying fractions is one of the most important applications of the idea of equivalent fractions. Equivalent fractions are fractions that have the same value but have different forms. For example, 1/2, 4/8, and 15/30 all have the same value, but they look different. If we are working with a fraction, a way to form equivalent fractions is by multiplying or dividing both numerator and denominator by the same number. For example, if we had the fraction 2/3, we could multiply both numerator and denominator by 3 to get the fraction 6/9. 2/3 and 6/9 are equivalent fractions. Or, if we had the fraction 10/12, we could divide both numerator and denominator by 2 to get the fraction 5/6. What does it mean to say that a fraction is simplified? The simplified form of a fraction is a new fraction that is equivalent to the original fraction and has the smallest possible whole number numerator and denominator. We simplify a fraction by finding numbers that divide evenly into both the numerator and denominator. Earlier, we took the fraction 10/12 and divided both numerator and denominator by 2 to get the fraction 5/6. There is no whole number greater than 1 that we can divide evenly into both 5 and 6, so 5/6 is the simplified form of the fraction 10/12. So, to simplify fractions, we have to find one or more whole numbers greater than 1 that divide evenly into both the numerator and denominator of a fraction. Sometimes this can be done easily just by looking at the fraction and noticing what number divides evenly into both numerator and denominator. For example, if we had the fraction 8/16, we might be able to see right away that 8 divides evenly into both the numerator and denominator, giving us the simplified form 1/2. But much more often, it isn't obvious just by looking at a fraction what whole numbers would divide evenly into both numerator and denominator. This is where using divisibility tests can be helpful. The divisibility tests that are most useful for simplifying fractions are the tests for 2, 3, 5, and 10. Let's review them. A number is divisible by 2 if it ends in a 0, 2, 4, 6, or 8. A number is divisible by 10 if it ends in a 0. A number is divisible by 5 if it ends in either a 0 or a 5. To decide whether a number is divisible by 3, add up the digits of the number. If the result is less than 10, stop. This is your final result. If the result is 10 or more, add up the digits of that result to get your final result. If the final result is 3, 6, or 9, then the original number is divisible by 3. You will notice that the divisibility test for 3 is a bit more complex than the divisibility tests for 2, 5, and 10. When using divisibility tests to simplify fractions, the process will go more quickly if you apply the tests in this order: 10, 5, 2, 3. Let's do some examples of fractions that can be simplified in one step. Consider the fraction 8/14. Neither 8 nor 14 end in a 0, so 8 and 14 are not both divisible by 10. 8 and 14 do not both in either a 0 or a 5, so they are not both divisible by 5. But both 8 and 14 are even numbers, so both are divisible by 2. 8 divided by 2 is 4, and 14 divided by 2 is 7. 8/14 equals 4/7. 4/7 is the simplified form of 8/14. As a second example, consider the fraction 20/15. Although 20 ends in a 0, 15 does not. So 15 and 20 are not both divisible by 10. But both 15 and 20 end in either 0 or 5, so both are divisible by 5. 20 divided by 5 is 4, and 15 divided by 5 is 3. So 20/15 equals 4/3. 4/3 is the simplified form of 20/15. Not all fractions can be easily simplified in one step, but before moving on to fractions that take multiple steps to simplify, it's worth practicing some one-step simplifications first. Let's summarize what we have learned in this video. Simplifying a fraction means to find a fraction equivalent to the original fraction that has the smallest possible numerator and denominator. We simplify a fraction by finding numbers that divide evenly into both the numerator and denominator. It is most efficient to first look at both the numerator and denominator to see if you can notice a number that you know divides evenly into both. After that, Apply the divisibility tests in the order 10, 5, 2, 3,